Hi guys, this week we're going to review all the different operations we've been doing with radicals. So no new material, but we will be combining everything from the past 3 lessons all at one time. So the first thing that we did was we simplified radicals. So remember, when you simplify radicals, you want to do a prime factorization and then look for groups the size of your index. So on example number 1, it's asking us to simplify. So notice that that's the square root of 250. I know it's a square root because there's nothing written here for the index, so remember that indicates that it's a 2. Over here, remember these are our parts of our radical, so you can refer to that. So if I'm going to do the prime factorization, 250, it ends in 10, so I can maybe try 25 and 10. My 25 breaks down to 5 and 5, my 10 to 5 and 2. So hopefully you're starting to get pretty good at this and can realize that I've got 5 times 5 times 5 times 2. And I need a groups of 2, so I've got 2 5s that can come out as a 5. This 5 and 2 don't have a group of 2 to stay or to come out, so 5 times 2 is just 10. So I've got 5 times the square root of 10. Now some of you might have been able to do that from at this point. See that you had 2 5s that could automatically come out as the 5, and your 5 times 2 was left over to give you the 10 underneath the radical sign. Moving on to number 2, we're still asked to simplify. So I look at that and I notice that this time I have an index of 3. So that means I need groups of 3 this time. I always have to be cognizant of whatever my index is. So I'm still going to do a prime factorization. 24, I can break that down a multitude of ways, but however you see it, maybe I'll do 4 times 6. My 4 breaks to 2 and 2. My 6 breaks to 2 and 3. So again, you notice my prime factors are 2, 2, 2, and 3. I need a group of 3 this time. So when I write that, 2 times 2 times 2 times 3, I do have a group of 3 2s. Remembering that index isn't going to change right there, that's a 3. So this group of 3 2s comes outside as a 2. My index stays the same, and this 3 had nobody to match up with, so that means that my result is 2 times the cubed root of 3. Now, another operation that we did, or the first operation that we did with our radicals, is that we multiplied them. So when you multiply radicals, you can multiply if they have the same index. Okay, so we have to be very careful to note what the index is, and then you can multiply any numbers outside the radical symbol and multiply anything inside the radical symbol. Remembering that you're going to add exponents of variables when you multiply. And then lots of times we'll have to take that and then simplify like we did on example 1 and 2. So on example 3, we're going to multiply. So I notice that my index is the same. They're both square roots, so I can simply multiply. So 6 times 216 gives me 1,296. And a lot of you, again, will be saying, well, that's an awfully big number. But remember, to do the prime factorization, to simplify that, I know that I multiplied 6 times 216. So I'm just going to go from there. I know my 6 breaks to 2 and 3. 216. Again, some of you might be thinking that's kind of big, but it's even, so I can divide it by 2. So that's what, 2 and 108. Still even, so I can say 2 and 54. 54 is a little bit more manageable. I could do by 2 again, or I also know that 54 is 6 times 9. 6 can be a 2 and a 3. 9 can be a 3 and a 3. So I've made my prime factorization. I have a 2 and a 3 and a 2 and a 2 and another 2 and a 3 and a 3 and a 3. So let's see, I've got 1, 2, 3, 4 2s and 1, 2, 3, 4 3s. Now, I can write all those underneath here. 2 times 2 times 2 times 2, 3 times 3 times 3 times 3. This is a square root, so I need groups of 2. So I notice I've got a group of 2 2s that can come out as a 2. I've got another group of 2 2s that can come out as a 2. I've got a group of 2 3s that can come out as a 3, and I've got a group of 2 3s again that can come out as a 3. Note there's nothing left underneath this one. So when I do 2 times 2 times 3 times 3, that's going to give me 4. And then times 3 is going to give me 36. So that means this problem, when I take the square root of 1,296, it's actually a perfect square. So if any of you noticed that straight away, you could have jumped right to the fact that it was 36. If not, your prime factorization always works. Number 4, we're also asked to multiply. Again, my index matches, so I'm able to do that. So I can multiply, let's see, 3x to the 7th times 8x squared will give me 24x to the 9th. Remember, I add the exponents when I'm multiplying, and my bases are the same. So now I'm just going to break this down. My 24, because I want to simplify if possible, I know my 24, let's see, that can be 4 times 6, 2 and 2, 2 and 3. Remember, again, it doesn't matter what factors you start with, you're always going to end with the same thing I have, that you would end up with 3 2s and a 3. And remember, my x to the 9th, if you will recall from our past lessons, I can write that all out, but I quickly grew weary of writing all of those out and seeing my groups. Remember, since it's a square root, I need groups of 2. So you'll see I have 4 groups of 2 and 1 left over. So that means that we're going to bring out x to the 4th. And here, instead of writing these under, I see that I have a group of 2 2s, so that means that's going to get to come out as a 2. These guys don't have groups of 2, and this x doesn't have a group of 2. That means that 2 and that 3 and that x are still going to be underneath the square root sign. So that means I end up with 2x to the 4th times the square root of 6x. Number 5, we're still multiplying. The difference here, recall, I've got coefficients I've got on the outside of my radicands. I multiply those as well. My indexes match, so I can go ahead and multiply. So I can do my 5 times 4 is 20. And the inside, we've got 6x times 8x to the 8th. Remember that that is 6x to the 1st. So when I do 6 times 8, that's going to give me 48x to the 9th power, because I remember I add the exponents. So I've got 20 times 48 x to the 9th. So now I'm going to simplify that. I can break down my 48 into 6 times 8. 2 and 3, let's see, this will give me 2 and 4, and then 2 and 2. So I've got a 2, a 3, a 2, a 2, and a 2. And my x to the 9th, well, I just did that on the last problem. So I'm going to do it without writing it out 9 times. I'm just going to take that 9, and since my index is a 2, I'm going to divide by 2. That gives me 4 with a remainder 1. That means that that's going to come out as an x to the 4th to join in with that 20. And then underneath my radical symbol, let's see, that remainder 1 means there's going to have to be an x under there. here, let's see, we had 1, 2, 3, 4 2s and a 3. So I have a group of 2s that are going to come out as a 2. I have another group of 2s. They're going to come out as a 2 to join in with that 20x to the 4th that's already there. And my 3x is left underneath. So I'm going to have to multiply my 2 times 2 times 20x to the 4th. So that's going to end up giving me 2 times 2 times 20 is 80x to the 4th times the square root of 3x. Now, we've multiplied and simplified, and the last thing we did last week, last operation, is that we added and subtracted radicals. Remember, you can only add or subtract radicals if they have the same index and the same radicand. So they need to have both the same index and the same radicand. Then you're going to simplify everything, add or subtract the coefficients, and keep the same radicand. Well, what does that actually look like? So as a reminder, if we look at example 6, we're supposed to add this. So I note I have to have the same index and the same radicand. So my index is a 2. Remember, there's nothing there, so that indicates it's a 2. And the radicands match. So all I have to do is combine the coefficients on the outside. So 3 times the square root of 7 plus 6 times the square root of 7 simply gives me 9 times the square root of 7. Very little work or effort needed. Now, when you look at number 7, we're still supposed to add those, but you'll notice that while the indexes match, the radicands do not. So what we need to do is try to simplify first to see if we can get the radicands to match. So when I simplify 27, I can break that down into, let's see, 3 times 9, and then 3 times 3. Well, I can get a group of 2 3s that can come out and join in with that 2 that was already out there, and that 3 has to remain. So 3 times 2 gives me 6 times the square root of 3. So since I've simplified this one, I know that I need to have radicands of 3 to be able to combine. So that's the first thing I try to divide by then. So I see that 75, can I divide that by 3? Sure, that'll be 3 times 25, and then my 25 breaks down into 5 times 5. Well, that's going to leave me a 3, and I've got 2 5s that can come on out to the outside. So that's going to give me a 5 times the square root of 3. 18 is also divisible by 3. However, my 6 is not a group of 2 of anything. So I'm not able to bring that to the outside. So, or I'm sorry, I'm lying. Look at this, I have a group of 2 3s this time. So my 3s are going to come on out as a 3. So that's going to give me 3, but what's left over is a 2. So you'll note that that does not match my other radicands. So the best I can do, I can combine these guys into 11 times the square root of 3, but this is just going to have to drop down because they don't match. So the best I can do is 11 times the square root of 3 minus 3 times the square root of 2. Our last example is also adding. So I have to simplify. Let's see, I can do 4 times 5, and I can break that into 2 and 2. So my 2 can come to the outside, and I can have 2 times the square root of 5. 45, I'm also able to divide that by 5, so that'll be 9 times 5. And my 9 breaks up into 3 times 3, which can come to the outside. So that's going to give me 2 times the square root of 5 plus 3 times the square root of 5. So that means that's simply 5 times the square root of 5.